The ocean has always had monsters, but for most of Earth's history, the word monster didn't mean what we use it to mean. It didn't mean something imagined, it meant something real, something in the water that made everything else afraid, something so large, so efficient, and so dominant that the entire ocean organized itself around its existence. For roughly 20 million years, that something was Otodus Megalodon, and nothing that has lived in the ocean before or since has come close to what it was. You think you know Megalodon, the enormous shark, the 60-foot monster, the thing from the movies with the teeth the size of hands, the animal that the internet insists is still out there, hiding in the deep. You know the image. You don't know the animal. Because the real Megalodon, the one the fossil record reveals when you actually look at it without the mythology layered on top, is simultaneously more impressive and more strange than anything popular culture has produced. It was not just a big shark. It was the apex of 400 million years of shark evolution, the end point of a lineage that had been refining the same basic design since before trees existed, pushed to a size and a level of dominance that the ocean has not seen since its extinction. And understanding what it actually was, how it hunted, what world it ruled, and why it vanished, changes how you see the ocean. Because the ocean you swim in today is a quieter, emptier, smaller place than the ocean Megalodon left behind. Start with the size, because the size is where every Megalodon conversation starts, and also where it most frequently goes wrong. For most of the 20th century, scientists estimated Megalodon's length by scaling up from the great white shark, comparing tooth size between the two species and extrapolating body length from there. The resulting estimates ranged from 52 to 67 feet, 16 to 20 meters. More recent work, using a broader range of skeletal proportions and more sophisticated modeling, has refined these numbers. The current scientific consensus places Megalodon at between 49 and 59 feet, 15 and 18 meters, for large adults, with some exceptional individuals potentially reaching 65 feet, 20 meters. That is not significantly different from the older estimates, but the newer research has added something older studies missed. Megalodon was not just long, it was massive. Its body was proportionally far heavier than a great white shark. Estimates of its weight range from 67 to 100 tons. For comparison, the largest great white shark ever reliably recorded weighed approximately 2.4 tons. Megalodon outweighed it by a factor of 40. This was not a scaled-up great white. It was a different category of animal, built differently, moving differently, hunting differently. The teeth. This is where Megalodon left its most direct evidence in the fossil record. Unlike bone, shark teeth preserve extraordinarily well. Megalodon shed thousands of teeth across its lifetime, and those teeth have been washing up on beaches and dredged from ocean floors for centuries. The largest confirmed Megalodon tooth measures 7.48 inches, 19 centimeters, along its slant height. The largest great white shark tooth reaches roughly 2.5 inches, 6.4 centimeters. The difference is not subtle. Megalodon's teeth were triangular, serrated along both edges, and built with a thickness that reflects the forces they were designed to generate. They were not built for slicing through soft tissue the way many predatory shark teeth are. They were built for cutting through bone, through the thick, dense bone of large whales. They were not the teeth of a fish eater. They were the teeth of a whale killer. The bite force. A 2008 study estimated the bite force of Megalodon at between 24,000 and 40,000 pounds, 108,000 and 180,000 newtons. A later analysis pushed the upper estimate to approximately 40,000 pounds, 182,000 newtons. For context, the bite force of a great white shark is estimated at around 4,000 pounds, 18,000 newtons. A saltwater crocodile, the strongest bite of any living animal, produces approximately 3,700 pounds, 16,500 newtons. Megalodon's bite was roughly 10 times more powerful than the strongest bite of any animal currently alive. It was capable of biting through the skull of a sperm whale, through the ribcage of a baleen whale, through almost anything that existed in the ocean it inhabited. The jaw that produced this force was enormous. Reconstructions based on tooth rows and scaling suggest a jaw opening of roughly 11 feet, 3.4 meters wide, and 9 feet, 2.7 meters tall. A fully grown human being could stand upright inside the mouth of a megalodon with room to spare. But a jaw is only part of the story, because the way Megalodon used that jaw is where paleontology has had to revise almost everything it assumed. For decades, the dominant model of Megalodon predation was simple. Big shark, big bite. Attack from below the way great white sharks do when hunting seals. The ambush model. Fast approach from deep water, explosive strike, retreat, wait for the prey to bleed out. It was a reasonable assumption, because great whites are Megalodon's closest living relative in terms of body plan, and the ambush strategy works. But when researchers began looking closely at the bite marks left on whale fossils from Megalodon's time period, the picture that emerged was completely different. The bite marks were on the wrong parts of the body. Great white sharks attacking large prey target the soft tissue, the belly, the flanks, the areas where blood loss is fastest and resistance is lowest. Megalodon bite marks on whale fossils concentrate on the hardest parts of the body, the shoulder girdle, the skull, the base of the flipper, the areas with the densest bone, areas that if disabled would prevent the prey from swimming. Megalodon was not trying to make the prey bleed, it was trying to immobilize it. A 2023 study in the journal Paleontologia Electronica analyzed bite marks on fossilized sperm whale skulls from the Miocene and found damage consistent with a large-toothed whale predator driving its teeth directly into the cranium. Multiple strike angles, evidence of repeated biting in the same location, not a feeding frenzy, a targeted assault on a specific structure. The conclusion was striking. Megalodon may have been more tactically sophisticated in its hunting than any living shark. It wasn't just a bite-and-wait predator. It was identifying vulnerable anatomical targets and attacking them with precision. In a 50-ton animal with a brain the size of a fist, that is extraordinary. The world Megalodon hunted in requires a separate understanding, because the ocean of the Miocene and Pliocene epochs, from roughly 23 to 3 million years ago, was not the ocean of today. It was warmer, substantially warmer. Global ocean temperatures during the peak of Megalodon's reign were several degrees higher than today's averages, and the warm, nutrient-rich shallow seas that result from higher temperatures are among the most productive marine environments possible. The coastlines of the Miocene were dotted with warm, shallow embayments. These were nursery environments, not just for fish, but for whales, because the baleen whales of the Miocene, the primary prey of the Megalodon, were coastal animals. They were smaller than modern baleen whales, between 15 and 30 feet, 4.5 and 9 meters long, and they gathered in warm, shallow water to give birth and nurse their young. Megalodon followed them there, not to hunt the adults, at least not initially, to hunt the calves. Fossilized whale bones from the Miocene coastal deposits show a consistent pattern. Young animals, juveniles and calves bearing Megalodon bite marks, adults far less frequently. The interpretation is uncomfortable, but ecologically logical. Megalodon was targeting the most vulnerable prey in the most accessible locations, not the 30-foot 9-meter adult with its bulk and flukes and its ability to fight back. The calf, the animal that hadn't yet learned to fear. The animal whose mother, species that had not evolved alongside Megalodon for long enough to develop adequate defensive responses, may not have been equipped to protect it. This is what apex predation actually looks like. Not the thunderous collision of giants that the movies depict. Efficient, calculated, targeting the weak. It was not less impressive for being strategic. It was more so. Megalodon did not inhabit a quiet ocean. This is one of the most important things to understand about the world it ruled. The Miocene ocean contained multiple large predators of extraordinary capability operating simultaneously. Leviathan melville, a sperm whale relative with functional teeth on both upper and lower jaws and teeth measuring 14 inches, 36 centimeters, was hunting the same prey in overlapping geography during the same time period. Early great white sharks, far smaller than Megalodon but effective predators in their own right, were present. Giant sea turtles, early dolphins, an ocean that, in terms of large predator diversity and prey biomass, has no modern equivalent. Megalodon sat at the absolute top of this ecosystem, but that position was not unchallenged. The question of whether Megalodon and Leviathan ever came into direct conflict is one paleontology cannot definitively answer. There is no smoking gun, no fossil of one with bite marks clearly from the other. What we have is geographic and temporal overlap. Two apex predators of incomprehensible scale, both hunting large whales in the same ocean for millions of years. Whatever their relationship, it shaped the behavior of every other animal in that ocean. The baleen whales that both predators hunted were not passive. They evolved in response to being hunted. Their descendants, the modern baleen whales, are among the fastest, most evasive large animals on the planet. The rorquals, blue whales, fin whales, sei whales are built for speed. They can sustain 15 miles per hour, 24 kilometers per hour, and burst to over 25 miles per hour, or 40 kilometers per hour. They are vastly more capable of escape than their Miocene ancestors. The evolution of modern whale speed was driven in significant part by millions of years of being hunted by something that could bite through their skulls. The ghost of Megalodon swims in every whale alive today. And then, approximately 3.6 million years ago, it was gone. The extinction of Megalodon is one of the most studied and still most contested questions in paleontology. The timing is clear enough. The last confirmed Megalodon fossils date to roughly 3.6 million years ago in the early Pliocene. What is far less clear is why. The leading hypothesis centers on climate. Beginning around 3 to 4 million years ago, global ocean temperatures began to drop significantly as the planet entered a period of prolonged cooling. The warm, shallow coastal seas that served as nursery grounds for the baleen whale calves Megalodon depended on began to contract. The calves were still being born, but they were no longer accessible in the warm, shallow environments that Megalodon was best adapted to hunt. The prey was moving into colder, deeper water, and Megalodon may not have been able to follow. There is evidence to support this. Modern great white sharks are warm-bodied, capable of maintaining body temperatures significantly above ambient water temperature, which allows them to hunt in cold water. Megalodon, based on isotopic analysis of its teeth, appears to have been even more strongly warm-bodied. An extreme endotherm, generating enormous body heat. In warm oceans, this was an advantage. It allowed faster metabolism, faster movement, higher energy output. In cooling oceans, it became a liability. An animal that massive, generating that much body heat, requires an extraordinary caloric intake to sustain itself. If the prey became less accessible, the energy equation didn't balance. The largest predator the ocean had ever produced may have starved to death, not slowly, not individually, but as a population, as the ocean it had been built for gradually became something it couldn't survive in. A 2024 study added another layer. It found that the extinction of Megalodon correlates closely with the emergence of modern killer whales. Orcas began developing their sophisticated cooperative hunting strategies approximately 3 to 4 million years ago. They are, by any measure, the most behaviorally complex predators the ocean has ever produced. They hunt in coordinated groups. They use strategy. They target specific prey. And critically, they compete for the same large whale prey that Megalodon depended on. Whether orcas actively drove Megalodon to extinction or simply occupied the niche it vacated is still debated. What is not debated is the timing. The rise of the most intelligent predator the ocean has ever produced and the disappearance of the largest coincide almost exactly. There is an idea that refuses to die. The idea that Megalodon is still out there. That something 50 feet, 15 meters long and 70 tons is hiding in the deep ocean undetected. It is not. The argument fails on multiple grounds. Megalodon was a coastal predator. It needed warm, shallow water and enormous quantities of large prey. The deep ocean is cold, dark, and prey-poor. An animal of Megalodon's size and metabolic demands cannot sustain itself in the deep. We also know that the Megalodon's prey, the large baleen whales, regularly come to the surface. If Megalodon was still alive, it would be hunting whales at the surface where we would see it. We have tracked whales with satellites for decades. We have never found the bite marks of a living Megalodon. We have found them in fossils, never on a living animal. Megalodon is gone. The certainty with which we can say this is actually a testament to how much we know about the ocean now, and it makes the animal's reality no less staggering. What is left of Megalodon is teeth, millions of them, scattered across ocean floors on every continent, washed up on beaches, dredged from sediment, sold in cases at roadside shops in the American Southeast, where the fossil-bearing deposits are particularly rich. You can hold a Megalodon tooth in your hand for $50. You can run your thumb along the serrations that once cut through whalebone. You can feel the weight of a tooth the size of your palm, and try to imagine the jaw it came from, and the animal behind the jaw, and the ocean behind the animal. That ocean is gone. The warm, shallow, whale-filled seas of the Miocene no longer exist in the form that produced Megalodon. The cooling of the oceans that killed it changed the world's water permanently. What we have now is a colder, quieter ocean, one where the largest predator is the orca, an animal that survives not by being enormous, but by being smart. The transition from Megalodon's ocean to the orca's ocean is in some ways a story about the direction evolution has taken, from size to intelligence, from brute force to cooperation, from teeth the size of hands to minds that plan ahead. Megalodon didn't fail to adapt. It was perfectly adapted to an ocean that disappeared beneath it. The beach where Megalodon teeth wash ashore in South Carolina was once the floor of a warm, shallow sea. The teeth sit in the sediment for millions of years, then slowly work their way toward the surface, carried by currents, revealed by erosion, until a child walking the tide line picks one up and holds it to the light, the serrations still sharp, the enamel still intact, a tooth from a world that no longer exists, in the hand of someone from a world that does. The ocean is still enormous, still mostly unexplored, still capable of producing things we haven't seen. But Megalodon is not one of them. It is gone, completely and permanently, and the ocean it would recognize no longer exists. What remains is the teeth, and the whales that swim faster because of what hunted their ancestors, and the quiet coastlines where once in warm, shallow water, the largest predator in the history of the ocean came to feed. The water looks the same. It isn't. Something that made the entire ocean afraid is gone from it, and the ocean has never replaced it. It never needed to. Nothing else was ever that big.